Hi guys, welcome to my study compass. In this video, I'll be walking you through the past paper Math P4 Variant 2 October-November 2019. Let's get started. Motion has 600 pear trees and 720 apple trees on his farm. Write the ratio pear trees is to apple trees in its simplest form. The ratio pear trees is to apple trees will be 600 is to 720. The highest common factor of the two numbers is 120. 120 goes into 600 5 times and 120 goes into 720 6 times. And so we have 5 is to 6. Each apple tree produces 16 boxes of apples each year. One box contains 18 kilograms of apples. Calculate the total mass of apples produced by the 720 trees in 1 year. Give your answer in standard form. To get the total mass of apples produced by 720 trees in 1 year, that will be 720 times 16 times 18 kilograms, which is equal to 207,360 kilograms. To write this figure in standard form, we move the decimal point at the end of the number to a point after the first non-zero digit, which is 2. This gives us 2.0736. Since we moved the decimal point 5 times to the left, we multiply 2.0736 by 10 raised to the power 5. 1 week, the total mass of pears picked was 18,540 kilograms. For this week, the ratio mass of apples is to mass of pears is 13 is to 9. Find the mass of apples picked that week. So for the week, we know the ratio mass of apples is to mass of pears is 13 is to 9. And so if the total mass of pears for the week was 18,540 kilograms, then what will be the corresponding mass of apples? This is what we are representing with x. When we cross multiply and make x the subject, this is what we have. When we type this into the calculator, we get 26,780 kilograms. The apples cost Motion $0.85 per kilogram to produce. He sells them at a profit of 60%. Work out the selling price per kilogram of the apples. The selling price will be 160% of the cost price. We've been told the cost price per kilogram is $0.85, and so the selling price per kilogram will be $1.36. Motion exports some of his pears to a shop in Belgium. The shop buys the pears at $1.50 per kilogram. The shop sells the pears for 2.30 euros per kilogram. The exchange rate is $1 equals 0.92 euros. Calculate the percentage profit per kilogram made by the shop. First, let's convert the selling price to dollars by setting up the conversion ratio. When we cross multiply and make x the subject, we get $2.50. The percentage profit made by the shop is equal to the profit divided by the cost price times 100%. We know the cost price is $1.50. The profit is the selling price minus the cost price, and so 2.50 minus $1.50 gives us $1. When we substitute these values into the percentage profit equation, this is what we have. When we type this into the calculator, we get 66.7%, rounded to 3 significant figures. Motion's earnings increase exponentially at a rate of 8.7% each year. During 2018, he earned $195,600. During 2027, how much more does he earn than during 2018? In other words, we want to find the difference between Motion's earnings in 2018 and 2027. We already know his earnings in 2018 is $195,600. To get his earnings in 2027, we apply the exponential or compound interest formula. This will be his initial earnings, which is $195,600 times 1 plus the annual rate, which is 8.7%, raised to the power 9, which is the time duration in years between 2018 and 2027. When we type this into the calculator, we get $218,814.31 rounded to the nearest cent. The cumulative frequency diagram shows information about the time taken, t seconds, for a group of girls to each solve a math problem. Use the cumulative frequency diagram to find an estimate for the median. To get the median, we map half of 80, which is 40, on the diagram. This gives us the median to be 54 seconds. Find an estimate for the interquartile range. The interquartile range is equal to the upper quartile minus the lower quartile. To get the upper quartile, we map 3/4 of 80, which is 60, on the diagram. This gives us 65 seconds. To get the lower quartile, we map 1/4 of 80, which is 20, on the diagram. This gives us 36 seconds. When we subtract 36 seconds from 65 seconds, we get 29 seconds. Find an estimate for the 20th percentile. To get the 20th percentile, we map 20% of 80, which is 16, on the diagram. This gives us 32 seconds. Find an estimate for the number of girls who took more than 66 seconds to solve the problem. When we map 66 seconds from the horizontal axis onto the cumulative frequency graph, we get 62, which represents the number of girls who took 66 seconds or less to solve the problem. And so to get the number of girls who took more than 66 seconds, we subtract 62 from the total number of girls, which is 80. 80 minus 62 is 18. Use the cumulative frequency diagram to complete the frequency table. At t equals 20, the cumulative frequency is 6, and at t equals 40, the cumulative frequency is 24, and so 24 minus 6 gives us 18. At t equals 40, the cumulative frequency is 24, and at t equals 60, the cumulative frequency is 50, and so 50 minus 24 gives us 26. At t equals 60, the cumulative frequency is 50, and at t equals 80, the cumulative frequency is 76, and so 76 minus 50 gives us 26. Calculate an estimate of the mean time. The mean is equal to sigma f of x, which represents the total sum of the time taken by all the girls to solve the problem, divided by sigma f, which is the total number of girls. Before getting sigma f of x, we need to get an average time for each of the time intervals. So for the first interval, the average time is 0 plus 20 divided by 2, which is 10. Then we have 20 plus 40 divided by 2, which is 30. 40 plus 60 divided by 2, which is 50. 60 plus 80 divided by 2, which is 70. 80 plus 100 divided by 2, which is 90. So for sigma f of x, we have 10 times 6 plus 30 times 18 plus 50 times 26 plus 70 times 26 plus 90 times 4 seconds divided by the number of girls, which is 80. When we type this into the calculator, we get 51 seconds. A group of boys solved the same problem. The boys had a median time of 60 seconds, a lower quartile of 46 seconds, and an upper quartile of 66 seconds. Write down the percentage of boys with a time of 66 seconds or less. The number of boys with a time of 66 seconds or less is the upper quartile value, which means 75% of the boys had a time of 66 seconds or less. Howard says the boys' times vary more than the girls' times. Explain why Howard is incorrect. We found the interquartile range for the girls in part AI as 29 seconds. To get the interquartile range for the boys, we subtract 46 seconds from 66 seconds. This gives us 20 seconds. And so Howard is incorrect because the interquartile range for the girls is higher than the interquartile range for the boys. A line joins point A with coordinates 1, 3 to point B with coordinates 5, 8. Find the midpoint of AB. When we apply the midpoint formula, the x-coordinate of the midpoint will be 1 plus 5 divided by 2, which is 3. And the y-coordinate will be 3 plus 8 divided by 2, which is 5.5. Find the equation of the line AB. Give your answer in the form y equals mx plus c. The equation of a straight line can be expressed in the form y equals mx plus c. We get the gradient m of the line by applying the gradient formula. This gives us 8 minus 3 divided by 5 minus 1, which is equal to 5 over 4. To get the value of c, we substitute the value of m and one set of coordinates. In this case, we are using 1, 3 into the equation. And so this gives us c equals 7 over 4. So now all we need to do is plug in the values of m and c into y equals mx plus c. This gives us y equals 5 over 4x plus 7 over 4. The line AB is transformed to the line PQ. Find the coordinates of P and the coordinates of Q after AB is transformed by a translation vector of 5, negative 2. For this transformation, we shift points A and B 5 units to the right and 2 units downwards to get the positions of points P and Q. When we move point A, we get the coordinates of P as 6, 1. And when we move point B, we get the coordinates of Q as 10, 6. Find the coordinates of P and Q after AB is transformed by a rotation through 90 degrees anticlockwise about the origin. For this transformation, we draw a line from each of the points A and B to the center of rotation. Then we measure and mark 90 degrees in the anticlockwise direction from these lines. The new positions will be pinned such that their distance from the origin is the same as the distance from the origin to their initial positions. When we rotate point A, we get the coordinate of P as negative 3, 1. And when we rotate point B, we get the coordinate of Q as negative 8, 5. Find the coordinates of P and Q after AB is transformed by a reflection in the line x equals 2. For this transformation, we reflect points A and B in the line x equals 2. When we reflect point A, we get the coordinate of P as 3, 3. And when we reflect point B, we get the coordinate of Q as negative 1, 8. Find the coordinates of P and Q after AB is transformed by a transformation by the matrix negative 1, 0 to negative 1. In this case, we need to multiply the transformation matrix by the coordinates of point A and B. To get the number in this position, we multiply the elements in row 1 of the first matrix with the elements in column 1 of the second matrix. This gives us 5. To get the number in this position, we multiply the elements in row 2 of the first matrix with the elements in column 1 of the second matrix. This gives us -3. To get the number in this position, we multiply the elements in row 1 of the first matrix with the elements in column 2 of the second matrix. This gives us 11. For the number in this position, we multiply the elements in row 2 of the first matrix with the elements in column 2 of the second matrix. This gives us -8. And so the coordinates of point P are 5, -3, and the coordinates of Q are 11, -8. Describe fully the single transformation that maps the line AB onto the line PQ, where P is the point -2, -6, and Q is the point -10, -16. Notice that when we multiply the x and y coordinate of point A by -2, we get the x and y coordinate of point P. The same applies for points B and Q as well. This means the transformation that maps AB onto PQ can be described as enlargement by a scale factor of -2 about the origin. The diagram shows a hemisphere with radius 6 centimeters. Calculate the volume. Give the units of your answer. The volume of a hemisphere is half of the volume of a sphere, so we have 2/3 pi r cubed. We've been given the radius of the hemisphere as 6 centimeters, and so when we type this into the calculator, we get 452 cm cubed rounded to 3 significant figures. The diagram shows a prism ABCDEF. The cross-section is a right-angled triangle BCD. BD is 10 centimeters, BC is 5.2 centimeters, and ED is 18 centimeters. Work out the volume of the prism. The volume of a prism is equal to its cross-sectional area times length. The length of the prism is 18 centimeters. In this case, the cross-sectional area of the prism is in the shape of a triangle. The area of the triangle is half of its base, which is the length of DC, times its height, which has been given as 5.2 centimeters. We can find the length of DC by applying the Pythagoras theorem to triangle BCD. This gives us 10 squared equals DC squared plus 5.2 squared. When we make DC the subject, this is what we have. 10 squared minus 5.2 squared is 72.96. When we plug in the length of DC into the equation and type this into the calculator, we get the volume to be 400 cm cubed rounded to 3 significant figures. Calculate angle BEC. To get the value of angle BEC, we can apply SOHCAHTOA. This gives us tan of angle BEC equals BC divided by EC. We've already been given the length of BC as 5.2 centimeters. We can find the length of EC by applying the Pythagoras theorem to triangle ECD. This gives us EC squared equals ED squared plus DC squared. ED is 18 centimeters, and we found DC in the previous question as square root of 72.96 centimeters. When we plug in these values into the equation and make EC the subject, this is what we have. 18 squared plus square root of 72.96 squared is 396.96. When we plug in BC and EC into the equation and make angle BEC the subject, this is what we have. When we type this into the calculator, we get 14.6 degrees rounded to 1 decimal place. The point G lies on the line ED and GD is 7 centimeters. Work out angle BGE. Angles on a straight line add up to 180 degrees, and so angle BGE equals 180 degrees minus angle BGD. We can find angle BGD using SOHCAHTOA. This gives us tan of angle BGD equals BD divided by GD. BD is 10 centimeters and GD is 7 centimeters. When we plug in these values into the equation and make angle BGD the subject, this is what we have. When we type this into the calculator, we get 55.0 degrees rounded to 1 decimal place. Hence, the angle BGE will be 180 degrees minus 55 degrees, which is equal to 125 degrees. The table shows some values of y equals x squared over 2 plus 1 over x squared minus 2 over x, where x cannot be equal to 0. Complete the table. When we substitute x equals negative 1 into the equation, we get y equals 3.5. For x equals 0.2, we get y equals 15.0. And for x equals 3, we get y equals 3.9. On the grid, draw the graph of y equals x squared over 2 plus 1 over x squared minus 2 over x for x is greater than and equal to negative 3 and less than and equal to negative 0.3, and x is greater than and equal to 0.2 and less than and equal to 3. So on the grid, we plot all the points from the table and connect the points with a smooth line. Use your graph to solve x squared over 2 plus 1 over x squared minus 2 over x is less than and equal to 0. In other words, we've been asked to find the x values of the graph where the y values are 0 and negative. On the grid, we see that this region is between x equals 0.55 and x equals 1.45. Find the smallest positive integer value of k for which x squared over 2 plus 1 over x squared minus 2 over x equals k has two solutions. For x is greater than and equal to negative 3 and less than and equal to negative 0.3, and x is greater than and equal to 0.2 and less than and equal to 3. In other words, we are asked to find the line y equals k that cuts the graph at 2 points. This k value needs to be the smallest positive integer value. On the grid, we see that y equals 1 cuts the graph at 2 points. This means k equals 1. By drawing a suitable straight line, solve x squared over 2 plus 1 over x squared minus 2 over x equals 3x plus 1 for x is greater than and equal to negative 3 and less than and equal to negative 0.3, and x is greater than and equal to 0.2 and less than and equal to 3. The line we need to draw on the grid is y equals 3x plus 1. So on the grid, we've drawn the line y equals 3x plus 1. From here, we need to note the point where the line cuts the graph. The x value for this point is 0.35. The equation x squared over 2 plus 1 over x squared minus 2 over x equals 3x plus 1 can be written as x raised to the power 4 plus ax cubed plus bx squared plus cx plus 2 equals 0. Find the values of a, b, and c. First, let's multiply through the equation by 2x squared. When we expand the brackets, this is what we have. When we move all the terms to one side of the equation and group like terms, this is what we get. A is the coefficient of the x cubed term, which is negative 6. b is the coefficient of the x squared term, which is -2. c is the coefficient of the x term, which is -4. The diagram shows triangle ABC. Use the cosine rule to calculate BC. When we apply the cosine rule to the triangle, this is what we get. BA is 13 meters, AC is 8 meters, and angle BAC is 79 degrees. When we plug in these values into the equation and make BC the subject, this is what we have. When we type this into the calculator, we get 13.9 meters rounded to 3 significant figures. Use the sine rule to calculate angle ACB. When we apply the sine rule to the triangle, this is what we have. When we make angle ACB the subject, this is what we get. When we type this into the calculator, we have 66.6 degrees rounded to 1 decimal place. The area of triangle DEF is 70 meters squared. Show that 4x squared plus 11x minus 300 equals 0. In this case, we need to apply the formula A equals half AB sine theta. We've been given the area as 70 meters squared. DE is x plus 4 meters. EF is 4x minus 5 meters. And angle DEF is 30 degrees. Sine 30 degrees is half, and so half times half is 1/4. When we expand x plus 4 times 4x minus 5, we get 4x squared plus 11x minus 20. When we multiply both sides of the equation by 4, this is what we get. When we move all the terms to one side of the equation and group like terms, we end up with 4x squared plus 11x minus 300 equals 0. Use the quadratic formula to solve 4x squared plus 11x minus 300 equals 0. Show all your working and give your answers correct to 2 decimal places. When we apply the quadratic formula to this equation, this is what we have. The numbers under the square root, 11 squared minus 4 times 4 times -300 gives us 4921. And for the denominator, 2 times 4 is 8. For the first possible value of x, we have 7.3 rounded to 2 decimal places. And for the second possible value of x, we have -10.14 rounded to 2 decimal places. Find the length of DE. DE is x plus 4 meters. When we substitute the positive value of x, which is 7.39 into this, we get 11.39 meters. Find f of -3. To get f of -3, we replace x in f of x with -3. This gives us 7 minus 2 times -3, which is equal to 13. Find h of g of 30. First, let's find g of 30. To get g of 30, we replace x in g of x with 30. This gives us 1/3. So now to get h of g of 30, we replace x in h of x with g of 30, which is 1/3. 27 raised to the power 1/3 is 3. Find f inverse of x. We know f of x is 7 minus 2x. In the first step, we replace f of x with x and replace x with y. When we make y the subject, this is what we have. This result we have for y is the same as f inverse of x, which means f inverse of x is also equal to 7 minus x over 2. Solve g of 2x plus 1 equals 4. To get g of 2x plus 1, we replace x in g of x with 2x plus 1. This gives us 10/2x plus 1. When we multiply both sides by 2x plus 1, this is what we get. When we expand the brackets, 4 times 2x is 8x, and 4 times 1 is 4. When we group like terms, this is what we have. When we divide both sides by 8, we get x equals 6 over 8. 2 goes into 6 3 times, and 2 goes into 8 4 times. And so our final answer here is 3 over 4. Simplify, giving your answer as a single fraction. 1 over f of x plus g of x. F of x is 7 minus 2x and g of x is 10 over x. We get the LCM by multiplying the denominators. 7 minus 2x goes into the LCM and we are left with x, which multiplies 1 to give us x. X goes into the LCM and we are left with 7 minus 2x, which multiplies the numerator to give us 10 times 7 minus 2x. For the numerator, when we expand the brackets, 10 times 7 is 70 and 10 times negative 2x is negative 20x. X minus 20x is negative 19x, and so our final answer here is 70 minus 19x over x times 7 minus 2x. Find h inverse of 19,683. We know h of x is 27 raised to the power x. To get h inverse of x, we replace h of x with x and replace x with y. Y is the same as h inverse of x. We want to find the value of y when x is 19,683. To make y the subject, we apply the basic definition of log. This gives us y equals log of 19,683 to the base of 27, which is equal to 3. Make p the subject of 5p plus 7 equals m. When we subtract 7 from both sides of the equation, this is what we have. When we divide both sides by 5, we get p equals m minus 7 over 5. Make p the subject of y squared minus 2p squared equals h. When minus 2p squared is moved to the other side of the equation, it becomes positive 2p squared. When h is moved, it becomes minus h. When we divide both sides by 2, this is what we have. When we take square root of both sides of the equation, we get plus and minus square root of y squared minus h over 2. Write OA as a column vector. To get to A from the origin, we move 0 units in the x direction and we move 5 units in the y direction. And so OA is 0, 5. Write AB as a column vector. To get to B from A, we move negative 3 units in the x direction and we move negative 1 unit in the y direction. And so AB is negative 3, negative 1. A and B lie on a circle center O. Calculate the length of the arc AB. The arc length of AB is theta over 360 degrees times 2 pi r, where r is OA. The length of OA is 5. Let's find the value of theta. If we draw a line from B to X, we form a right-angled triangle. B is 3 units from the origin in the X direction, and so BX is 3. B is 4 units from the origin in the Y direction, and so OX is 4. We can find theta using SOHCAHTOA. This gives us tan theta equals 3 over 4. When we make theta the subject, this is what we have. When we type this into the calculator, this is what we get. When we plug in the values of theta and OA into the arc length equation, this is what we get. When we type this into the calculator, we get 3.22 rounded to 3 significant figures. Car A and Car B take part in a race around a circular track. One lap of the track measures 7.6 kilometers. Car A takes 2 minutes and 40 seconds to complete each lap of the track. Car B takes 2 minutes and 25 seconds to complete each lap of the track. Both cars travel at a constant speed. Calculate the speed of car A. Give your answer in kilometers per hour. Speed equals distance over time. Car A travels one lap of the track, which is 7.6 kilometers, and the time it takes to travel one lap is 160 seconds. We divide 160 by 3600 to convert it to hours. When we type this into the calculator, we get 171 kilometers per hour, rounded to 3 significant figures. Both cars start the race from the same position S at the same time. Find the time taken when both car A and car B are next at position S at the same time. Give your answer in minutes and seconds. It takes car A 160 seconds to complete one lap of the track, and it takes car B 145 seconds to complete one lap of the track. By finding the LCM of these two numbers, we are able to get the time duration that both cars arrive at their initial starting point. One of the ways to get the LCM is to multiply 160 and 145 and divide by the HCF of 160 and 145, which is 5. And so it takes 4,640 seconds for both cars to arrive at their initial starting point. To convert this value to minutes, we divide by 60, which gives us 77 1/3 minutes. To convert 1/3 minutes to seconds, we multiply by 60. 1/3 times 60 is 20. And so our final answer is 77 minutes, 20 seconds. Find the distance that car A has traveled at this time. Distance equals speed times time. The speed at which car A travels is 171 kilometers per hour. The time duration is 4,640 seconds. We divide this by 3,600 to convert it to hours. When we type this into the calculator, we get 220.4 kilometers. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.